Now that we know how much money you're spending, let's see where all this money goes. This is a pie chart, and what it states is that 50% of your electric bill goes towards heating and AC, 30% towards water heating, 8% towards appliances, 7% towards lighting, and 5% towards cooking. Now, if you're going to pick one of these areas to try to reduce, which one do you think you'd pick first, Matt?
AC.
AC, right? That's 50% of your bill. What do you think you'd pick second, Joan?
Water.
Water heating, right? That's 80% of your power bill. I try to urge all homeowners to understand that's where most of your money goes. AC is 14,000 watts, water heater is 9,000 watts. That's 80% of your power usage. Make sense?
It does.
Okay, great. Now, over time, traditional insulation deteriorates, allowing energy to enter and exit our homes, and lack of proper insulation causes us to waste billions of dollars on energy every year. Now, where your energy dollar is lost the most is due to lack of proper insulation. And you see here I have a thermal image of a home's energy loss with typical mass insulation. And you can see, where's most of that energy being lost, Joan?
In the roof.
Through the roof, right, Matt? You see that red? Red is bad, right? 42% of the energy loss in a residential home goes straight through the roof, right? Now, in the summer, attic temperatures can rise to over 150 degrees, increase your energy costs by over 30%. Now, believe it or not, Matt, Joan, there's actually 3 forms of heat transfer. You've got convection. That's when warm air rises, transfers heat to the ceiling, right? Kind of like a convection oven, it's got that fan in there, keep even heat through the whole oven. Then you have conduction. That's the transfer of heat through a solid material, right? You heat up one end of a pole, you better not touch the other end, right? It's going to transfer that heat, right? That's conduction. And then you have radiant heat. That's the transfer of heat through electromagnetic waves, right? And today we know that radiation is the single most significant source of heat loss and heat gain in your home. Does all that make sense, Matt?
Yes.
Joan? Okay, great. Now, radiant bearifax in the mid-1950s when Clark E. Beck refined the technology for NASA in the form of a thermal blanket, which is still used globally by emergency crews today. Now, radiant barrier technology was introduced into the U.S. Space Agency Hall of Fame in 1996 and was considered a top-secret technology until the early 1980s. Now, the U.S. Department of Energy says when a radiant barrier is correctly installed, it can reduce heat gains through your ceiling by over 97%. Now, Oak Ridge National Laboratory showed a 24% energy savings, and the St. Louis, Missouri facility showed a 26% energy savings. Now, radiant barrier technology allows Top Fuel NHRI racers to walk away from the 2,500 plus degree temperatures experienced during high-octane fuel explosions. Y'all ever watched NASCAR before?
Oh, yeah.
You ever seen a car on fire? They go throw that silver blanket over top of them, right? That's the, reflective insulation they're talking about. I think I actually have a sample of it here somewhere. Oh yeah, here we go. Right? You ever seen this kind of stuff before, Matt?
I feel like I have. I don't know
This
where.
is reflective insulation. It's the new type of insulation that they're using. You've seen this stuff before. You probably just didn't know it. You ever seen, the astronauts or the space shuttles? That silver stuff that they put in there. Believe it or not, this was developed by NASA in the 50s. They used to line all the space shuttles, space suits, block out the sun's radiant heat, protect the astronauts. In space, it's 200-degree temperature swings from 1 hour to the next. So they had to come up with something that would protect them that was lightweight, right? Believe it or not, they spent $50 million developing this product, right? And you see it all the time. You just don't realize it. You ever seen the pizza man come over? You look in that little bag he's got, right? That silver stuff in there. That's reflective insulation technology. It's the same stuff, right, that they used in NASA. Or you ever seen those things that you kind of unfold? You put it into your windshield. You come out of the mall 5 hours later. You don't burn your butt on the seat. Ay. You know what I'm talking about, Matt? Right? That's reflective insulation technology. They also use this stuff for a lot of coolers and things like that. You'll see it used as well. And today they actually make a type of this stuff that goes on the inside of your attic space, right? And what that does is block out all the heat from being able to come into your attic. But it doesn't go on the floor, it actually goes on the rafters, right? See, you kind of got to think of how your house is set up. You've got your attic here, and you got your house here, and you got your AC here. Now this AC is producing cold air somewhere in the neighborhood of 40 to 50 degrees. And you're trying to keep your home at what temperature, Matt?
About 76.
76. The heat in the attic is between 120 and 180 degrees. So how hard do you think this AC has to work to maintain a temperature of 76 degrees in the house when you have all that heat in the attic?
Pretty hard.
It's got to work really hard, right? Extremely hard. Now, the sun rises in the east and it sets in the...
West.
You're absolutely right, sir. Sets in the west, right? 1 for 1. Comes up around 7 a.m. and it sets around
7 p.m.
7 p.m. You got it. Yeah, there's somewhere in there. It really depends on the time of the year. And this sun kind of goes over your house all day long like this. Now, between the hours of 7 a.m. and 10 a.m., your AC is maybe kicking on 1 to 2 times an hour to maintain the temperatures that are inside this home, right? Between the hours of 10 a.m. and 2 p.m., this is when the sun is high in the sky. This is the time my mother used to not let me go outside unless you rub lotion, you know, sunscreen, right? During that time, your AC is maybe kicking on 3 to 4 times an hour to maintain the temperatures that are inside this home. And between the hours of 2 p.m. and 7 p.m., unfortunately, this AC almost never stops. Now, a lot of people ask me, like, Chris, you know, I've noticed that. I'm getting home from work, kids are getting home from school. That's the time I want it to be the coolest. That thing's just running and running and running. Why is that, right? Well, believe it or not, the reason is this insulation here. This insulation acts like a sponge, absorbing the heat. It's kind of like one of those sponges you see in your kitchen. You know those sponges that got the green on the top, yellow on the bottom? Phil, you seen those before, right? Imagine if you took that sponge and you left it on the sink for a couple days till it completely dried out, right? Then you turned on the water and you put that dry sponge underneath the faucet. What's going to happen to the water? Or what's going to happen to the sponge?
Soak it up. Right?
It's going to start absorbing the water, right? Now, once that sponge has absorbed all the water it possibly can, what happens to the rest of the water?
Overflows.
It just runs off, right? The same thing happens with this insulation. Around 2 o'clock, this insulation gives up. It's absorbed all the heat it possibly can, and it can't absorb anymore. Then that heat starts barreling into the house, right? You ever gone away on vacation or maybe for the week? You tell your wife, hey, turn that AC up a little bit. We're not going to be here, right? Instead of turning it up, you accidentally turn it off. You come back after being gone all week or all weekend, you throw that front door open, you get hit with that heat wave, right? It's hotter on the inside of your house than it is on the outside of your house. That's because heat compresses in the attic, right? And when it can't get up, it goes down, right? And it starts pushing its way into this home, right? Now, they make a product called reflective insulation that actually goes on the rafters here. And what that's going to do is it's going to block out 97% of the sun's radiant energy. If it's blocking out 97% from even coming into the attic, how much of that heat does your insulation have to handle?
3%.
3%. Now also keep in mind, all of your AC ductwork runs through the attic. So what you're doing is taking 50-degree cold air, pumping it through a 150-degree attic space before you funnel it into your living area. You end up losing 10 or 15 degrees of that cold air by the time it actually makes its way into your house. You see how reflective insulation will reduce that process, eliminate that process, reduce the strain that you're putting on your AC system? Does that make sense, Matt?
It does.
Absolutely. Cut.